Uh, so basically today's topic is demystifying layer two. So many of you might be knowing about layer two, but yeah, it's a bit easy concept relating relative to all the things we'll be discussing in the lecture series. So let's get started. So basically, the first question is what is layer 2? So we see many of the chains such as Polygon, Arbitrum, Optimism, Linea, ZK Sync, and all. So all these chains are called layer 2 scaling solutions. These are basically scaling solutions for Ethereum layer 1. So what is a layer 2 scaling solution? So basically, layer 1 itself is not that much capable when it comes to transaction speed, when it comes to transaction throughput, and also the in terms of the gas fees. So these are a few drawbacks that a layer 1 always poses, and there are layer 2 present to solve that issues. So first of all, what is the need of layer 2? So before going into that, let's discuss few questions. So first of all, the first question would be why to scale a blockchain? So what is the need of scaling a blockchain? And the second question would be why Ethereum layer 1 is not scalable? And the third question would be how can layer 2 solve the scalability issues? And as you can see this meme over here, so this is basically a screenshot taken from a video clip that was issued by I guess some peeps at Solana, mocking Ethereum L1s. Uh, like they said that in this video, the Ethereum chains always need various layer one, layer two, layer three, layer four over there. So in order to function, so so that was a funny meme over here. So let's move to the first question. Why to scale a blockchain? So basically, over here I have put two examples. The first being the 2017 bull market. Uh, in 2017, there was a trend of ICOs. ICOs, you might be knowing, initial coin offerings. So ba basically, various projects like started offering their own coins and tokenomics, and they were able to pause the entire L1 for a while because of the large volume of transactions the ICOs had caused. And the second example would be again the 2020 bull market. In the 2020 bull market, there was a DeFi boom. So basically, the decentralized finance and the yield farming stuffs are in trend in 2020. And basically, people went for performing transactions in order to gain profits and yield high APRs. So basically, that caused the L1 to surge the gas fees up to 500 to 700 GWI. That is insanely high. Basically, as you can see, uh, we might see over here. I think my screen is not visible for the other tab. Just a minute. Mm, yeah. So we can see over here the current gas fees over Ethereum L1 is around 16 GWI, and I was talking about 500 to 700 GWI during that crypto market boom. Uh, so yeah, basically these were the problems that need to be solved while scaling a blockchain. The layer one possesses these kind of slow transaction issues as well as high gas fee issues, and as well as the chain might get halt for very few seconds. That may cause instantly transaction pause and etc. You might have heard that recently Solana chain had faced a chain halt for few seconds, and that basically caused 75 or 80% transaction to be paused for a while, and they didn't get processed. So moving on to next question, why Ethereum L1 is not scalable? So Ethereum by its own, like on its design, performs around 12 to 15 transactions per second, and that is its current transaction per second, or TPS. And also, considering the price of Ethereum token, the average gas fees that is being charged for an transaction is around $1.5 per transaction. But it's not like limited to $1.5 per transaction. It can go up to thousands of dollars for like complex code executions, such as any governance proposal execution. Like I have seen around thousand, $1,200, $1,500 of gas fees for a single execution. So this is the gas fees is very much high when considering L1 in the Ethereum L1. Also, so why cannot we just scale the L1 to use like higher performing nodes? So basically, like if anyone can argue that we can use very high performant nodes and make the transaction processing very faster, but that would basically cause us a problem. That is the blockchain scalability dilemma. Anything you can say. So basically, when we try to scale up the L1 using high performant nodes, the initial capital investment to run a node basically increases and causing the like the verification power and node running power to a specific group of like elite people, and that would basically reduce the decentralization. Also, there will be uh, less number of nodes running because of the limitations, because of the resources needed. So the chain would be vulnerable to various attacks. Like you might have heard 51% attack. That is caused when the 51% of your chain, 51% of your validators or nodes is basically being hijacked. So they can change any transaction or any values or any data on the chain to whatever they would like. So basically, scaling the layer one uh, directly would not be possible, as that would basically decrease the decentralization and security of the chain. So, how to scale a blockchain without compromising on security and decentralization? So, the answer is L2. Basically, L2 provides its solution by like basically L2 is not changing the L1 at all. L2 is on the top of L1, and it tries to like bundle the transactions over it tries to bundle the transaction over the L2, and after bundling it, it puts it into L1 and verifies it. So basically, it uses all the security features of the L1, and also it doesn't uh, like harm the decentralization of the chain. So moving ahead, so why layer two? So layer two, as I mentioned, doesn't require any changes on the base chain, and it leverages the security of the layer one while providing the higher TPS. So basically, layer two, as you can see, like as you might be knowing, in Arbitrum or in Polygon, like the transaction per second is around like in thousands. So in Polygon, last I remember was 65,000 transactions per second when compared to Ethereum L1, that is 5 to 15 or something like that. Also, Layer 2 provides lesser gas price because because like they run on like higher capable machines. Their nodes are on higher capable machines, and the transaction speed therefore increases. And also, they provide higher transaction throughput because, like, uh, what do you mean by throughput? Uh, what kind of number of transaction at a single time can be verified? So this is basically L2 provides. And L2 can be for general purpose, for example, proving any smart contract, or running any function on smart contract, or swapping tokens, etc., etc. And the L2 can also be application specific. For examples, in case of Bitcoin, we do have Lightning Network, that is an L2, that is only specifically made for payments, and that is an example of application specific L2. And general purpose L2 can be Arbitrum, Optimism, Polygon, etc. That is basically based on Ethereum L1. So moving on to the next part, how layer 2 works. So there are various architectures in which like the layer 2s are implemented. In order to implement the layer 2, we do have few architectures listed over here, such as state channels, side chains, optimistic rollups, as well as JK rollups. So let's go one by one, with the list. And before moving on to the list, let's see the table over here. So basically, this table signifies the transaction per seconds. For example, Bitcoin have 7 transactions per second. Ethereum is around 12. And the Lightning Network, that is a layer 2 of Bitcoin, is around 1 million transactions per second. That is estimated around. And in Polygon, around 60,000, as I mentioned earlier. And Optimism, Arbitrum, around 100 to 1,000 per second. And yeah, the ZK rollups such as Starknet and ZK Sync around 1 million and 20,000, and so on. So basically, also these are the fees per transaction. So as you can see, transaction in the Ethereum and Bitcoin network is a bit higher. Transaction fees are a bit costly, whereas in the L2s, they are pretty cheap. So moving on to the various type of layer 2s. First of all is state channels. So what are state channels? State channels are basically a type of layer 2 solution in which there are two or more parties involved, and they can perform multiple off-chain transactions, like person A trying to send like multiple transactions to person B, and vice versa. But they basically submit only one or two transaction at the end to the chain. So by doing this, basically they are like reducing the number of transactions that is put on the chain, and hence reducing the transaction cost, as well as reducing the speed, settlement time, and all. So in order to perform these state channel transactions, you need to be a multi-sig. So basically, you need to stake a few of your Bitcoin, or in case of Lightning Network, few of your Bitcoin, and basically then you can start doing this multi-party transaction that is being verified off-chain, and then you can put only single transaction or two transaction to the Bitcoin network, and hence verify the transactions. So as I mentioned, Lightning Network is a like very good example of state channels. So let us move ahead with Plasma. So Plasma was basically a scaling solution of like it was introduced by Vitalik Buterin, the founder of Ethereum. But it's not that popular among the layer 2 solutions. Basically, in Plasma, what happens is there is a parent chain, and there are various child chains or children chain. And the children chain and the parent chain can communicate whenever required. So the child chains can basically broadcast whatever like information they want to into the parent chain. And it is a bit like technically difficult to understand plasmas. So these are not that much used, and we see very less examples of plasma. So let us move ahead with side chains. Side chains, as you might have heard of Polygon, and basically side chain is a chain, basically as the name justifies. Uh, for a parent chain, side chain is a chain that basically have its own consensus mechanism, as well as it can have their own validation facility or own validators or miners for proof of work, or like proof of stake. They have validators. So basically, Polygon is a POS network, proof of stake network. And while Ethereum was a proof of work network, Polygon used to be a proof of stake network then. And basically, they had their own validators. That is a different consensus mechanism from the L1. And like they had their own way to reward their miners or validators. Basically, sidechains compromises on the security in order to gain a larger speed of transactions. So basically, the main chain is linked to the side chain and vice versa. The parent chain can work independently, but the side chain cannot work without a parent chain. So basically, it helps in interoperability. How the sidechains function is like you basically bridge some of your assets from the parent chain to the side chain, and you perform your transactions, and then you put the transactions and the remaining assets to the L1. Uh, so basically, for example, we have Matic Bridge or also Circle CCTP that acts as a federation or bridge in order to provide us access to the side chains. And in side chains, basically, you lock your tokens on the L1, and basically you release the token when basically whenever your transactions are complete on L2. And these locking and releasing mechanisms are done by the federation. And since the involvement of this federation, the side chains basically are considered less secure. For a few examples are like Polygon, as I mentioned, and XDAI or Gnosis in today's day. So let us move ahead with optimistic rollups. So optimistic rollups are basically a type of. So before going into optimistic rollup, let us discuss about rollups itself. So rollup, as the name justifies, a lot of transactions are rolled up into a piece of paper, just imagine, and then it is put into the L1. So basically, it is bundling of lots of transaction and then putting it in the L1. So in rollups, basically transactions are not directly put into the L1. Instead, the transaction data is there. So instead of transaction getting registered on the L1, we basically just put the data of a collective transactions to the L1, and hence we verify all the transaction in the bundle. So optimistic rollup is a type of rollup solution. Basically, in optimistic rollup, the name justifies itself. So we become optimistic about the transactions happened in the bundle, and we think that we basically assume that all the transactions are correct, and we basically have what do you call it? Uh, a dispute time in which someone can just raise a dispute that the following transactions are wrong, and if they are found wrong, they are removed, and the remaining bundle is put into the L1. But if the dispute time is passed and no transaction is found malicious, then the whole bundle gets passed into the L1, and the transaction data is registered there. So few examples are Arbitrum, Optimism, and Base network. Let us move ahead to ZK rollups. So ZK rollups basically mostly ZK snarks. So here I have written the full form of ZK snarks. ZK snarks refers to zero knowledge succinate non-interaction argument of knowledge. So we don't need to know all of that at the beginning. We are going to learn about in the next series. Uh, so ZK rollup basically, as the name justifies, provides zero knowledge about the transaction in the bundle. Basically, uh, understand like that. In the transaction, suppose A sends few ETH to B, but while we just put the transaction into the L1, there is no mention of A or B or the amount of ETH that is being transferred. So how ZK rollups work? ZK rollups basically they generate a off-chain proof, validity proof, and the validity proof is then submitted to the L1, and hence the transaction is verified in that way. Also, ZK rollups are pretty fast when compared to optimistic rollup, because optimistic rollup has that dispute raising time. And yeah, so ZK rollups are also the drawback ZK rollups possesses are they do not support smart contracts yet, whereas optimistic rollups have their optimistic virtual machine that can support smart contracts. So ZK rollups basically works on circuits and not smart contracts. So that is a drawback to get started with. But a few examples that have successfully implemented ZK rollups are ZK Sync, Starknet, Linea, and Polygon ZK EVM, etc. So that's all for a brief about the L2s. We'll see about ZK rollup and optimistic rollups in the next few lectures in detail. So yeah, that's all.